In the recent times, when the height of the Mount Everest was measured, we got to learn that the height is increasing by more than 1 centimeter per year. Another interesting aspect is that way back in the year 1954, for the first time, when Edmund Hillary and Tenzing Norgay reached onto the top of the Everest, they scaled a height of 8840 meters. But for any mountaineer who's reaching onto the top of the Everest today, they had to scale 86 centimeters more than what Edmund Hillary and Tenzing Norgay had to scale. This is because the Mount Everest is present in a tectonically active region. See, the variation in the height is not just confined to the Mount Everest. There are more than 110 mountains which are having a height of 7,300 meters. One gets to see the variation in these mountains as well. It is because the Himalayan ranges are present in a tectonically active region. And those places which are present in the tectonically active region, the variation is quite common. In order to understand the upliftment of the Himalayas and the formation of the Himalayas, one has to have an idea on the concepts of continental drift theory, the plate tectonics, and the structure of the interior of the earth as well. My name is Madhusudan Reddy. I am the Faculty of Geography GS and Optional at the IIShub. In today's video, I'll be trying to explain all of these concepts. Hello aspirants, my name is Madhusudan Reddy and I'm the Faculty of Geography at the IIShub. At the end of this video, there is a big announcement that we are going to make. Please make sure to watch this video till the end. First, let us try to understand the structure of the interior of the earth. Once you learn the concepts of the structure of the interior of the earth, we will be trying to apply these concepts to plate tectonics, continental drift, and the upliftment of the mountains as well. देखिए, the interior of the earth is divided on the basis of chemical composition and the mechanical composition. One has to have an idea about both of these compositions, and one should compare these two compositions as well. That is when they have a clarity about the internal structure of the earth. देखिए, first let's try to study the chemical composition. The chemical composition of the earth has three different layers. The topmost layer is your crust. Beneath the crust, you have your mantle, and beneath the mantle, you have your core. The mantle is further divided into upper mantle and lower mantle. The core is further divided into outer core and inner core. When you come to the mechanical composition, here the earth is divided into layers. The topmost layer is your lithosphere. Beneath the lithosphere, you have your asthenosphere. And beneath the asthenosphere, you have your mantle. Mantle is further divided into upper mantle, intermediate mantle, and lower mantle. And beneath this layer, you have your core. Now, core is further divided into outer core and inner core. When you look into the mechanical composition and compare it with the chemical composition, you will learn that the lithosphere layer is nothing but the crust plus upper part of the upper mantle in the chemical composition. Now this lithosphere is a solid material. Now beneath this solid material, you have your asthenosphere in the mechanical composition. When you compare the asthenosphere to that of the chemical composition layers, your asthenosphere is nothing but the lower part of the upper mantle. And this asthenosphere is neither solid nor liquid. It is made up of semi-fluidic material. It has a buoyancy properties. In simple words, your asthenosphere will let the lithosphere to float over it. And beneath the asthenosphere, you have your mantle. This mantle, as you go deep inside, the density of the material increases and the temperature also increases. Beneath this mantle, you have your outer core and inner core. Outer core is liquid and inner core is solid. Subset denser material will be near to the core, and subset lighter material will be present next to the crust. Now let's learn little more detail of the plates. देखो, plates are nothing but the lithospheric plates. When you cut the lithosphere into multiple pieces, now each of this piece is considered to be a plate. वैसे ये plates दो तरह होता है. One is a continental plate, other is an oceanic plate. Your continental plate is dominantly made with granitic material, and the oceanic plate is dominantly made with basalt. the density of the oceanic plate is more and the density of the continental plate is less. And all of these plates, they are actually floating over the asthenosphere. As and when they float, sometimes they collide with each other, sometimes they move away from each other, sometimes they move parallel to each other. See, if two plates are moving against each other or coming together, that plate is called as convergent boundary, or else the boundary between them is called convergent boundary. If two plates are moving away from each other, the boundary between them is called as divergent boundary. If two plates are moving parallel to each other or slide past each other, the boundary between these plates is called as transform boundary. Our agenda is to understand the upliftment of the Himalayas and the variation in the height, so largely we'll be confining ourselves to the convergent boundaries. There are three types of convergent boundaries. Now, the first type of convergent boundary can be between a continental plate and a continental plate convergence. The second type can be the convergence between continent and an ocean. And the third type can be the convergence between ocean and oceanic plate. देखिए, जब भी एक oceanic plate और oceanic plate converge होगा, the older oceanic plate will be more denser and the older oceanic plate will sink and the younger oceanic floor will start to rise. Whenever an oceanic plate and a continental plate, they collide with each other, the oceanic plate sinks and the continental plate rises, because the oceanic plate density is more as compared to the continental plate. And the third case, which we have discussed, that continental-continental collision. This continental-continental collision is the result of the upliftment of Himalayas. The examples of the oceanic plate include the Pacific plate or the Nazca plate, and the continental plates are your Eurasian plate or your African plate. There are also plates which are made up of both continent as well as ocean. Let's take the example of South American plate. On the western side, you find the continent, and the eastern side, you have your ocean. So majorly, most of the plates are made up of both continent and oceans. The formation of the Himalayas are the resultant of the collision between the Indian plate and the Eurasian plate. Eurasian plate is also a continental plate, Indian plate is also a continental plate. So as both the plates collided with each other, convergence हुआ था, इसी कारण neither of the plates sank into the mantle because उन दोनों का density same है. So that's the reason why the upliftment of the Himalayas took place, and continuously the plates are moving. As and when these plates move, the height of the Himalayas increases because the folding is continuously active. But there are also mountains, they are also formed because of the collisions of the continent and continent. The best examples are your Urals. लेकिन Ural mountains height आज भी increase नहीं होता, लेकिन Himalayan का mountain height, it keeps on increasing. Why? Again, to understand this, you have to go back to 250 million years before. See, India was once part of a bigger landmass called Gondwana land. Is Gondwana land में majorly the Gondwana land consists of South America, Africa, India, Madagascar, Australia and Antarctica. Slowly, when India started to move towards north, there was a sea that was present, and the sea between the Indian plate and the Eurasian plate was called Tethys Sea. And Tethys Sea is considered to be an oceanic plate. So as and when India started to move towards the north, the Tethys Sea plate was also colliding with the Eurasian plate. And Tethys Sea being an oceanic plate, the Tethys Sea plate went and sank into the mantle at the boundary of Eurasian plate and the Tethys Sea plate. Over a period, the Tethys Sea plate completely succumbed into the mantle. And today, the Indian plate goes and collides with the Eurasian plate. But still, within the mantle, the partial melting process is still active. So that's why the plate that got subducted into the mantle by the name of Tethys Sea plate, it is still going and reaching into the core. That's why our lithospheric plate is still actively moving towards the north. Thus, the Himalayas are on the continuous rise. ये एक दो दिन में नहीं हुआ था. It happened over a period of millions of years. The Himalayan mountains started to form in three different phases. In the first phase, the Trans-Himalayas formation took place, and little later, after few millions of years, again the upliftment of Greater Himalayas, and continuously you also see the formation of four deeps, and the four deeps has led to the formation of the sediments of the Himalayas came into the four deeps. And ये फोर डीप इज नथिंग बट जब भी एक माउंटेन बनता है, माउंटेन के सामने एक बड़ा सा वैली बन जाता है। ये वैली को कहा जाता है 4 डीप। इसी 4 डीप के अंदर all the materials that are being taken by the rivers, they deposit themselves into the 4 deeps, and the material that got deposited into the 4 deeps, they again get uplifted because of the folding. Likewise, our Himalayan upliftment took place in 3 different phases. Thus, the formation of Greater Himalayas, followed by the Lesser Himalayas, and then the Shivaliks. देखिए, Himalayas are also considered to be the barriers of culture, they are also considered to be the barriers of climate. आज अगर हिमालयास ना होता, इंडिया के ऊपर स्नो भी देखने के लिए मिलते, एंड हिमालयास होने के कारण देर आर स्पीशीज, different set of species you will get to see. Those species which are present in the Tibet are different from the species that you find in the India. Himalayas height is continuously rising. You got to know it now. But because of this, Himalayas are also considered to be one of the most tectonically active region जहाँ पे earthquakes हर साल देखने के लिए मिलता है. इसके कारण the Himalayan states are very vulnerable to disasters. On the other side, Himalayas also acts as a cultural barrier. The cultures that you see north of the Himalayas is different from the south of the Himalayas. The climates are different north of the Himalayas and south of the Himalayas. Even the monsoons that are coming from the south are being, the Himalayas act as a barrier there. So overall, Himalayas protects us. Himalayas are considered to be the lifeline sources for major states in the north. The IIShub has given more than 1,000 plus selections in the last 5 years. And we at the IIShub firmly believes that the youth has great potential and they have every right to reach their destinations. But कई सारे ऐसे students हैं, because of their financial constraints, they are not able to reach that destination. Not just financial constraints, अगर आपको knowledge constraints है या directionless हो गया आप, या आपको mentorship ना मिलने के कारण आप अपनी मंजिल ना पहुंच पा रहे, तो एक IIShub आपकी और आपकी सक्सेस के बीच में एक ब्रिज बनना चाहता है. So that's why we at the IIShub are going to come up with a scholarship test. We will conduct the scholarship test and based on your performance you will be given the scholarship. There is a link that is given in the description. Please make sure to register there and take the scholarship.